Hi friends, today topic is sums, symmetry and addition or multiplication. Symmetry and addition or multiplication. The symmetry and addition multiplication. The sums involving even, odd, even and odd functions have the following properties. Even and odd functions have the following properties have the following properties. The sum of two even functions is even, and the sum of two odd functions is odd. The sum of an even function and odd function is neither even nor odd, provided that neither of the function is identically zero. That is, the sum of functions with the same type of symmetry is also has the same type of symmetry. Products involving even and odd functions have the following properties. Products, first one is sum, second one is products. In this also we are seeing three rules. The product of two even functions is even. The product of two odd functions is even. See the difference. The sum of two odd functions is odd, but in the product of two odd functions is even. See the differences from the sum and products. The sum of two odd functions is odd, but in the product of two odd functions is even. The rules will be changes. The product of an even function and an odd function is odd. From the above, the sum of and even and odd functions neither even nor odd. But in this, the product of an even function and odd functions is odd. That means the rules are quietly opposite with respect to the sum and products. That is, the product of functions with the same type of symmetry is even, while the product of functions with opposite type of symmetry is odd. That means it is exactly opposite to the sums. Next one is decomposition of a signal into even and odd parts. Decomposition of a signal into even and odd parts. Every function x has a unique presentation of the form. Every function of x has a unique representation of the form. X of t equal to xc of t plus x naught of t. X of t equal to xc of t plus xo of t, where xc is the even number and xo is the odd number, where the function xc and xo are the even and odd numbers respectively. In the particular, the function xe and xo are given by the xe of t equal to half of x of t plus x of minus t, and xo of t is equal to half x of t minus of x of minus t. That means the convenience, the function is even and odd parts of x are often denoted as even x and odd x respectively. These are the different roles, which is helpful to simplifying the problems at the situation. We know the some common rules. The sum of even numbers is dash. The sum of odd numbers is that. The product of even numbers is dash. The product of odd numbers is dash. So these are all the most important rules to simplifying or solving the problems. And next one is sum of periodic functions. Sum of periodic functions. Periodic functions means which will indicate some or assigning some particular value to the pulses. Let x1 and x2 be a periodic functions with fundamental periods t1 and t2 respectively. Then the sum y equal to x1 plus x2 is a periodic function, and it is only if the ratio t1 by t2 is a rational number. Rational number. Suppose that t1 by t2 equal to q by r, where q and r are the integers and coprime have no common factors. Coprime means have no common factors. Then the fundamental period of y is rt1. rt1. Although the above theorems only directly addressed in the case of sum of the two functions, the case of n functions where n greater than 2 can be handled by applying the theorem respectively n minus 1 times. n minus 1 times. These are the other rules. Right-sided signals. Right-sided signals. A signal x is said to be right-sided if, for example, just we are considering a signal x is said to be right-sided if for some finite real constant t naught the following conditions hold: x of t equal to 0 for all t tends t less than equal to t naught, where x is only potentially non-zero to the right of 2 naught. For example, we are seeing the below diagram. It is a right-sided signal. That means the signal will propagate through the right side to t naught to t. That means the signal will propagate through the right side. That's why it is called right-sided signal. For example, signal will be propagated through the negative side. That means that is called left-sided signals. If the signal is propagates through the right-sided, that is called right-sided signals, and if the signal is propagates to the left side, that is called left-sided signals. A signal x is said to be causal if x naught of t equal to 0 for all t less than or equal to 0. A causal signal is a special case of right-sided signal. A causal signal is a special case of right-sided signal. A causal signal is not to be focused with a causal system. In these type of contexts, the word causal have has very different meanings. Causal have very different meanings. That means the overall concept of symmetry Symmetry means adding. Symmetry means adding, addition, multiplication, and decomposition of signal into even and odd parts, and sum of periodic functions, and right-sided signals and left-sided signals. These are all the explaining different rules for to applying these rules when we are solving the problems. For example, we are seeing it is a right-sided signals, and it is a left-sided six. In right-sided signal, the wave is propagated from right-sided, or the signal is propagated from right-sided. But in left-sided signal, the signal is propagated to the left-sided. So these are the different fundamental rules. Those are more helpful to solving the problems. So at the situation we are using these conditions, and also we are using some rules of symmetry and addition multiplication. The sum of two even functions is even number. The sum of two odd functions is odd number. The sum of even and odd functions neither even or not nor odd. At the same time, the product of two even numbers is even, and the product of two odd numbers is even, and the product of even number and odd number is odd. So compared to sums and even numbers, product numbers is different, and all are used to explain the behavior of the signals. Thank you. Next class we are discussing more topics. Thank you.